Welcome to Homework Lib.
We have been given some survey data. The sample size is 1,000, and we are told that out of these 1,721, the head of household commutes by car. We want a confidence interval for the percentage of households in the town that meet this criteria. And the population size is pretty large, something like 50,000. Let me actually check that again. How many households are in the town? Yep, okay, 50,000. Can we make this confidence interval? Right, so the first step is to check that this is appropriate. We need the sample to be random, which I believe it is, and we need the sample size to be no more than 5% of the population size. If the sample is pretty large compared to the population, then by the time you take your last member of your sample, you've really changed the proportion left behind that meet your criteria. So for them to be reasonably independent, you need a large population. We just have that here. Very close, but we have it. And we have random sampling. The final check is that NP and N1 minus P should both be at least 10. That's 10 successes and 10 failures. We have that easily. So number of successes here is 721. Failures is 279. So we can make this interval. The formula is P hat, sample proportion, point estimate, plus minus the margin of error, Z root P hat, 1 minus P hat over N. This gives us a confidence interval for the population proportion. I will turn it into a percentage at the end. All of your calculations should be in decimal or fraction form. Percentages won't work out. So we have N. P hat is the proportion of the sample that meet the criteria, 721 out of 1,000, so 0.721. We get Z from the level of confidence. If I was to take every sample of this size, take the mean at the proportions and plot them out, I'd get something approximately normal. Our interval needs to be wide enough to contain the middle 95% for 95% confidence. That leaves 5% in the tables, so each tail is 2.5%. Z is the Z score to exclude those. You may have a table of these. If not, use the inverse normal function to get 1.960. Now let's use this formula. So 0.721 plus minus the error, which I will get now, 0.721 multiplied by 0.279 divided by 1,000, square root that, multiply it by 1.96. The error is 0.0278. If I take that away from the point estimate, I get the lower bound of my interval. How many decimal places? It doesn't say. Okay, 0.693. If I add it on, I get the upper bound of my interval, 0.749. That's, again, as a proportion, so the last thing we have to do is just multiply by 100 to get the interval for a percentage. That is our answer.